Hello friend, I Tushar Tuwar, Assistant Professor in Civil Engineering Department at Dr. Subhash Technical Campus Junagadh. Here in this video lecture series, subject of design of structure in semester 5th, and this lecture series is based on IS 456 and I hope familiar IS 456. It is a Indian National Building Code. In this video lecture use design of different types of structure element like beam, column, slab, footing. Next, different types of load. In general, the load on structure are classified three types: vertical load or gravity load, horizontal load, or next longitudinal load. First, vertical load. Vertical load are three types of category: dead load, live load, or wind load. First, dead load, denoted by DL, capital D into L. IS 875 पार्ट 1 1987 डेड लोड का कोड है. व्हाट इज डेड लोड? डेड लोड की डेफिनेशन: डेड लोड इज इन ए बिल्डिंग इंक्लूड द वेट ऑफ ऑल permanent construction like floor, partition hall, balcony, roof, beam, lintel, wall, column, footing. Next, live load, denoted by LL, or imposed load, denoted by IP. लाइव लोड का कोड है IS 875 पार्ट 2 1987. What is live load? The load which are not steady but keep on changing position from time to time are called live load or imposed load, like weight of person, furniture, cars, moving partitions. Okay. Next, हॉरिजॉन्टल लोड. हॉरिजॉन्टल में टू टाइप्स के लोड है, विंड लोड और अर्थक्वेक लोड. फर्स्ट, विंड लोड. विंड लोड का कोड है IS 875 पार्ट 3 1987. व्हाट इज विंड लोड? विंड लोड इज कंसिडर्ड इन डिजाइन ऑफ टॉल बिल्डिंग और टॉल बिल्डिंग. ठीक है. The force exerted by the horizontal component of wind is to be considered in the design of building. It is depend upon velocity of wind and shape and size of the building. Second, earthquake load. Earthquake so cause movement of foundation of structure. What is earthquake? It is cause shaking of the ground in all three directions along the two horizontal direction X and Y and vertical direction Z. Next, five topic cover in this subject. First, introduction. Second, analysis and design of beam. Limit state method. Third, design for shear, torsion and bonding. Fifth, design of compression member. Analysis of design of beam. Analysis and design beam. Singly beam, doubly beam, T-beam, cantilever beam. Analysis and design these types of beam. And design for slab. One-way slab, two-way slab, continuous slab. Design for compression member like column, footing, circular column, rectangular column, footing, pad footing, trapezoidal footing. ठीक है. Next, what is IS 456-2000? तो जो हमारा सब्जेक्ट है डिजाइन ऑफ स्ट्रक्चर, उसमें दो पोर्शन रहता है, आरसीसी और स्टील. आरसीसी के लिए IS 456 कोड यूज होता है. IS 456-2000 में वो कोड रिवाइज हुआ है. तो IS 456-2000 इज इंडियन नेशनल बिल्डिंग कोड, प्रोवाइड गाइडलाइन फॉर डिजाइन and construction of structure and work from collective wisdom of expert structure engineer to bring them in line with current research and obtain current trend. Okay, next, objective of structure design. Plain concrete versus reinforced cement concrete. Basic property of concrete. Basic property of steel. Generally, multi-story building like using construction material concrete and steel. Two types of force, tension force and compression force. Like this force is compression, this force is टेंशन. कंक्रीट है जो आरसीसी मतलब प्लेन सीमेंट कंक्रीट, वो कंप्रेशन रेजिस्ट करता है, और स्टील का पोर्शन है वो टेंशन रेजिस्ट करता है. ठीक है. नेक्स्ट, disaster management of India. 2600 people die every year due to building collapse. Year 2013, 7-story building collapse in Thane, Maharashtra. Reason for failure of substandard construction material. Strength. Stress should not exceed the critical value. Next, "40-meter curve and collapse. Flyover, Kolkata." Stability. Stability. What is stability? A structure system is a state of equilibrium if the construction permits no rigid body movement upon application load, like overturning, buckling, sliding, should be prevent. Next, serviceability. What is serviceability? It implies satisfactory performance of the structure under service load without discomfort to the use due to excessive deflection, cracking, vibration, and so on. Other considerations that come under privilege of serviceability are durability, acoustic, and thermal insulation like stiffness, deflection, impermeability, and durability. Next, strength, stability, good structure design, strength, stability, and serviceability. Next, planning phase. The first, planning phase. Second, structure analysis and design. Third, are the safety and serviceability requirements satisfied? Satisfied, no. Again, revise structure design. Okay. Next, structure analysis and design satisfied, yes. Construction phase. First phase, planning phase. Planning phase may carry out by architecture planner to plan the layout of the structure. Second, functional requirement, aesthetic requirement. Next, structure analysis and design. Select the most appropriate structure system to bring the architecture concept into bring estimation of load, structure analysis for estimation of stress, structure design. Third, of actual proportional size, reinforcement, etc. for safety and serviceability, submit the drawing. Next, concrete and reinforced steel. First, plain concrete is made by mixing cement, aggregate, water, and admixture. Concrete is generally prepared at the site itself. Ready-mix concrete and precast concrete are also used. Concrete compressive strength is very high. Concrete tensile strength is very low, negligible as compared to its compressive strength. Okay, next, concrete and reinforced steel. Steel embedded in concrete, reinforced steel bar undergo yielding, hair crack, no ductility model of failure under heavy load. Usually manufactured in factory under control condition. It can effectively take up the tension induced due to flexure tension, direct tension, diagonal tension, environment effect. Steel also impart ductility of material. Compressive strength is more than concrete. Next, grade of concrete. Discuss about our grade of concrete. Characteristic strength of concrete, modulus of elasticity of concrete, tensile strength, creep, shrinkage, and last, durability. Grade of concrete. Design property of concrete are This is measure to standard test on concrete cube. Cube size 150 mm by 150 mm by 150 mm. M for mix and 20 characteristic strength 28 day expressed in Newton per mm square. Okay, next. This is measured by standard test of concrete cube IS 456 2000 table number 2. High strength concrete about 60 M60 M65 70 75 80 85. Standard concrete grade M25 to M55 M25 M30 M35 M40 M45 M50 and 55. Normal strength concrete M10 M15 and M20. Okay, next. Grade of concrete: ordinary concrete grade, standard concrete grade and high strength concrete grade. So ordinary concrete grade M10 15 20. Characteristic strength: compressive strength of 150 mm cube at 28 day Newton per mm square. M10 to 10, M15 to 15, M20 to 20. Standard concrete M25 to M60 and high strength concrete M60 to M100. Characteristic strength: even well collect them, some mix but 3. Compressive strength is not same. Definition: what is characteristic strength FCK? It is what is characteristic strength? It is defined as the strength of material below which not more than 5% result are expected to fall, subjected to considerable variation in strength. The variation in concrete is expressed in terms of standard deviation and coefficient of variation. So coefficient of variation is equal to standard deviation divided by mean strength. The target mean strength is equal to FCK plus 1.65 standard deviation. Value of standard deviation, grade, stress Newton per mm square, M10 to M15 as per IS 456 2000. Standard deviation value M10 to 15 3.5 and M20 to 25 4, greater than 30 so 5. Next, Young modulus of elasticity. What is Young modulus? Young modulus of elasticity of concrete is also called Young modulus of elasticity at origin. EC is equal to 5000 under root FCK, characteristic strength of concrete. Second Young modulus of elasticity of concrete, slope of line joining at any point with the origin. Tangent Young modulus of elasticity is the slope of tangent on the any point on the curve. तो यहाँ पे स्ट्रेस स्ट्रेन कर्व दे रखा है, हॉरिजॉन्टल में स्ट्रेन है, वर्टिकल में स्ट्रेस है। ठीक है, नेक्स्ट मॉड्यूलस ऑफ इलास्टिसिटी। कॉन्क्रीट ब्रिटल मटेरियल, कॉन्क्रीट और ब्रिटल मटेरियल टू टाइप्स में होता है, नॉन लीनियर और नॉन इलास्टिक। ओनली इनिशियल proportion of curve is linear. The modulus of elasticity is equal to stress divided by strain. उसमें दो टाइप का रहता है, शॉर्ट टर्म इलास्टिक स्ट्रेन, लॉन्ग टर्म इलास्टिक स्ट्रेन। शॉर्ट टर्म इलास्टिक स्ट्रेन इंस्टेंटेनियस लोड और क्रीप एंड श्रिंकेज। शॉर्ट टर्म इलास्टिक modulus of elasticity and effective modulus of elasticity. Okay, next Young modulus of elasticity. As per IS 456-2000, Young modulus of elasticity of concrete is EC is equal to 5000 under root FCK. FCK is equal to characteristic strength of compressive अथवा compressive characteristic strength. Okay, next. As per IS 456-2000, Young modulus of elasticity of concrete is EC. Modulus of elasticity of concrete is equal to 5000 under root FCK. For example, for M25, M for mix 25, characteristic strength compressive Newton per mm square. So EC is equal to 500 into under root FCK. So 5000 under root 25. So 5000 into 5 is equal to 25,000 Newton per mm square modulus of elasticity of concrete. Next, possible types of short-term strain. Initial tangent modulus ITM उसको बोलते हैं tangent modulus TM और second modulus SM. Empirical formula for static modulus given by IS 456-2000 clause number 6.2.3.1. Modulus of elasticity is equal to 5000 under root FCK based on initial tangent modulus ITM. Next, (7 to 15% of compressive strength, tension strength test, direct tensile stress, split test, and flexural tension test. Next, (7 to 75) compressive strength, डायरेक्ट टेंशन स्प्लिट फ्लेक्सुरल स्प्लिट टेस्ट. जो सिलेंडर रहता है उसका हम स्प्लिट टिंग टेस्ट करते हैं. ठीक है, बीम का 3 पॉइंट मेथड से टेस्टिंग टेंसाइल स्ट्रेस टेंसाइल टेस्ट करते हैं. उसमें जनरली बीम की साइज 100 mm by 100 mm by 500 mm, सपोर्टिंग पिन टू और लोडिंग. ठीक है, नेक्स्ट मॉड्यूलस ऑफ रैप्चर FCR. The theoretical maximum tensile stress reached in extreme fiber. Empirical formula suggestion by code. Modulus of rupture is equal to 0.7 under root FCK. Relation between tensile and compressive stress. M by Z. M points bending moment in Z section modulo Z. Creep. Time dependent component of total strain. Two types के strain, instantaneous strain, creep strain. Both depend on stress level. Creep coefficient theta is equal to creep strain time and instant creep strain divided by instantaneous strain. Next, creep coefficient for design as per IS 456 2000 clause number 6.2.5.1 7 day, 28 day and 1 year. Theta is equal to 2.2 7 day, 28 day 1.6 and 1 year 1.1. तो हॉरिजॉन्टल में टाइम दे रखा है और वर्टिकल में टोटल स्ट्रेन जो स्ट्रेन है और अल्टीमेट क्रीप स्ट्रेन इंस्टेनियस स्ट्रेन सडनली फिर कर्व. ओके, नेक्स्ट श्रिंकेज. Concrete shrink harden state due to lose of moisture by evaporation. Dry shrinkage, reduction in volume of concrete similar to creep induced time dependent strain. Unlike creep independent of stress level, shrinkage resistance develop tensile stress lead of crack. Differential shrinkage due to moisture or thermal grading or due to unsymmetrical place reinforced steel in base. Three types: induce internal stress, curvature or deflection. Shrinkage strain for design expressed as linear strain as per IS 456 clause number 6.2.4.1 0.0003 mm per mm. Next, what is durability of concrete? Concrete is serve the purpose for which is designed during its independent lifetime. Some factors which affect the durability of concrete. Internal factor, external factor. The first internal factor, the property of ingredient used make concrete alkali, reactive aggregate and salty water. Second thing, external factor environmental effect. The effective way to increase durability, provide adequate cover to embed steel using coated steel, using appropriate minimum grade of concrete according to environment exposure condition. Okay. Now, we are concluding our session. If you any further question or want to additional information, please contact or comment. Thank you.